Hi everyone, welcome back to my channel. For those of you that are new here, my name is Ellie. I'm currently an astrodynamics software engineer and I'm a Cambridge mathematics graduate, and today I'm going to be reacting to the very famous YouTube video which is Animation versus Physics. This has been very highly recommended on my channel, especially after I reacted to Animation versus Math a couple of weeks ago, so if you haven't already seen that then check that out. I'm hoping that as an applied mathematician and someone who is currently working in the space industry that my physics knowledge will be okay for this. Let's dive straight into it. Okay, let's go. Whoa. Whoa, is that like the Big Bang? Because it was like a big flash of light. Sorry, I'm already analysing, I just need to watch. Okay, so we're in space. Stickman's floating through space. I mean, that's already quite a good setting for a physics video. Gravity? Yeah, okay. So, first thing I've noticed is space in the background, which is obviously very physicsy, and he's just hit some surface. I'm assuming this is going to be a planet, so we've already got gravity. Stickman, which obviously we need. Are we going to go with like a similar black and white theme like we had in... Whoa, distance. Oh cool, it's got units in as well. That was something that I thought in the maths video, in the animation versus math, and I get why, but there were no units, so it's nice that we have units here. Okay. So we've got distance, velocity, okay, nice. Velocity arrows, yep. So he's stationary now, or he stood still, so the velocity is 0 meters per second, which makes sense, and he's moved 1.3 meters. Okay, so this is basically very simple, I guess, starting mechanics. You know, you've got things like distance, velocity, and I assume we'll have acceleration in just a moment. Oh, displacement. Oh, nice. Okay, cool. Velocity. Okay, so we have velocity 1, velocity 2. This is going to be acceleration. Because it's 2, okay, so it's 2, typically with acceleration, it's like the difference between two velocities over time, and we've got two different velocities here, so yeah, we've got acceleration, and Stickman is running. Do you know what's actually really nice? In the animation versus math, when Stickman was running, he used like a multiplication sign to like power up in a sense and to go faster, and obviously that's not really possible. I guess it is in games and stuff, but what's quite nice already is that we see the physics behind what's happening, and I understand that's because it's animation versus physics, but I think I will probably like this animation more because it's like real world, if that makes sense. Not that math isn't real world, I am a mathematician, so mathematicians don't come for me in the comments, but yeah, I quite like that this is physically, like it's representing, you know, physical stuff. So, okay, we're in a minute in. Friction. Okay, so he's fallen over. Yeah, friction's been brought into play there. That's nice. Okay. Is that like Newton's apple falling on his head? Or is it just a ball of some mass that's fallen on his head? Where did that even come from? Is it a snowball? A kilogram? Mass. Yeah, nice. Okay, I called it. Ah, okay, force equals mass times acceleration. Yeah, okay, nice. Whoa, I've just missed a bit there. So we've got force equals mass times acceleration, which of course is Newton's second law. I don't know if like the ball falling on his head is like alluding to the apple that fell on Newton's head. I quite like that subtlety there. And then we have work. Okay, nice. It's taking me back to my mechanics lessons. Power. Trajectory is cool. Okay, this is awesome. Yeah, this is literally just taking me back to my mechanics lessons. Whoa. Okay, so we had hang on a second. We had friction, mu equals 0.5. Ah, okay. So he's on some sort of ice, which means he's sliding around because there's not as much friction. So he's on ice and he's trying to get up, which he can't do. That's quite nice. The when he falls and seeing the force down, so I think it was like 50 newtons there. That was quite nice. And we have a rope now. This was my issue last time, is everything just goes so fast that yeah, it's hard to follow along without pausing and trying to understand what's going on. So apologies for the amount of pausing. So we have a rope now, which has come from absolutely nowhere. I think it's come from a star. He's trying to reach it. He's got it. Okay. Okay, so he's tied it around the ball. Oh, nice. Okay, he's using... Oh, okay. He's using angular momentum. Very nice. I learned this. I remember learning this very vividly in one of my first year modules at university, and we were learning about angular momentum and ice skaters, and I would try to demonstrate it right now, but I'm probably going to knock something over. But it's where, due to the conservation of angular momentum, essentially ice skaters, when they have their arms out like this and they're spinning, when they then bring their arms in, they end up spinning faster, and that's due to the conservation of angular momentum. So is he going to start doing some pirouettes? Stickman going to do some dancing, some ice skating for us? Okay, so we've got angular momentum. Precession, nice. Yeah, okay, so he's using... Oh, nice. There's linear momentum as well. So he's using the angular momentum to drive himself forward. And now he's doing a bit of ice skating. Very nice. Yeah, he's got momentum going forward. Fantastic. Okay, now he's going to hit. Are we going to have Newton's third law? Equal and opposite forces. So now there's a... What? This is already throwing curveballs at me. There's a tree, which I assume is alluding to Newton's tree, that the apple fell. I don't know, there's so much going on. So we have a big ball and a little ball. Stickman's propelling himself forward, so he's pushed the ball. Hang on, what does that say? Oh, that's so cool. Oh, whoa, okay, so it's going, okay. So when the ball gets pushed, we have potential energy that's then converted to kinetic energy and then back to potential again. Okay, that's really cool. I like that. I really like that animation. What's going to happen now? Stickman, I assume, is going to try it himself. Use the string as a bit of leverage. Okay. Is he going to... Yeah, he's not going to make it. Okay, so... I assume he's going to go back and just like try stretch the string out even further. This is so different to animation versus math, but I love it because it's okay, he's gone. I need to just stop talking because everything happens so fast. Okay. Oh, and he's got an excess of kinetic energy. Amazing. So he's propelled a bit further. And now he has another rope. What is that? A rocket? Why is there... Okay, yeah, fine, sure. Cool. Just a random floating rocket. Nice. I don't even know. Is this meant to be Earth? I have no idea. Okay, so he's using the ball to propel. Is he gonna... He's gonna use this ball to throw himself up to the... Oh, whoa, okay, we've got torque. Okay, so... Thank you to whoever commented in my previous video that told me I can move frame by frame by pressing the comma and the dot button. I didn't know that was a thing, and every time I kept rewinding, so I know that now. Thank you for that, whoever commented that in my previous video. So torque is essentially a turning force that causes rotation around an axis. So here, when Stickman jumps, essentially it's I think this is the turning axis here. It's where the dot is, where like just above the torque. And when he jumps, that rotates around an axis, and I assume that's the axis there. So cool, we've got torque in here now. Wow, going back to my like mechanics days. So he's tying this rope. Okay, so I have a feeling he's gonna like right. The big ball's gonna tighten the rope, and then I think he's gonna somehow propel himself up into the rocket. He's gonna need a lot of like centrifugal force for that. Okay, maybe it's not actually that high as the rocket. This must have like quite... Whoa. Oh, that's so cool. So he's essentially, he's thrown himself, he's propelled himself, he's generated enough force from what he's just done to reach this rocket through like a centrifugal motion, you know, spinning. Yeah, that's crazy. This actually, this is what I get for working in the space industry, but this reminds me of a company, I think it's called Spin Launch. So what the company does is they have, I think it's like, it's going to be a satellite, and they essentially spin it around. So they generate so much centrifugal force that then when they release it, it then gets shot up. And they're trying to release rockets and like spacecrafts using that method. So using this exact method that we've just seen, which is ridiculous. The amount of like G's that are on that when it's propelled. Yeah, someone will never be able to sit inside that because they would die. Yeah. But anyway, that's just what that reminded me of. So kind of cool that we've seen it here, and it's also actually something that companies are trying to do in real life. Yeah, so he's escaped gravity. Like, no one can physically throw themselves up to a rocket like that. So I've just got to... I mean, Stickman can. This Stickman can practically do anything. So anyway, he's on a rocket. Oh, that's brilliant. I wish rockets started like that in real life. Okay, we've got some thrust now, I believe. Yep, thrust, amazing. And we now have a cowboy hat. Cool. This ain't his first rodeo. So his speed is constant. So it's constantly generating thrust. His speed is increasing. There's the massive tree. So I think Stickman's trying to... Whoa, hang on. So, oh, we have the Lorentz factor. Okay, right. So from what I've observed, Stickman is trying to get to this star, I think, maybe like another planetary system. He's on the rocket. He's going at 99 meters per second because that's velocity. Beta here, the velocity that you're going at relative to the speed of light. So because it's 0.00000, it's essentially saying that the velocity that Stickman is currently going at is so minor compared to the speed of light, because the speed of light is, I think, 300 million meters per second. So yeah, 99 meters per second isn't even scratching that, you know, it's not scratching the surface. But the really cool thing is the Lorentz factor. So the Lorentz factor is basically, what are the three things? It's time, mass, and distance, I think. It could be, or is it length? I'm trying to remember from my from my lectures. I think it's those three things, and it's basically the factor at which those three things change when you approach the speed of light. Okay, so we've got the Lorentz factor. That's kind of cool. So I wonder whether Stickman is going to approach the speed of light at any point. It would be quite nice to see. I really hope he does, because then we can see things like time dilation and hopefully black holes. This shirt that I'm wearing, it's one from Brian Cox's tour, and it's essentially the Penrose diagram on here. So I wore it in hope that something on black holes would come up. That, and I'm just a nerd. So yeah, I hope something on black holes comes up now. Sorry, I'm getting sidetracked. Let's go. Okay, so 99 meters per second. Nowhere near the speed of light. Oh, whoa, what the heck? He's got hit in the head with a torch. Whoa, what? There's a moon behind him? This must be some very durable torch to actually work in space. Oh, nice. Alright, okay, so hang on. So there we saw the speed of light, because obviously there's light emitting from the torch itself. Oh, there you go. That was the exact speed of light. That I think it's like 299 something, and now, okay, everything's going so fast, and now we're passing through the electromagnetic spectrum. Very cool. This is already an incredibly interactive tour of our physical world, which I think is absolutely insane, and it reminds me a lot of a course that I did on scientific thinking on Brilliant.org. So for those of you that don't know, Brilliant is a platform where you learn by doing, with thousands of interactive lessons in mathematics, data analysis, programming, AI, technology, you name it. There's loads of courses on a range of different STEM subjects. It's great because each lesson encourages problem solving, but also allows you to play with concepts, and this kind of method is 6 times more efficient than simply watching lectures. What I love so much about Brilliant is the ability to build a powerful daily learning habit, so you can pick up your phone or your device and learn little by little each day. And in doing so, you can earn points and join really cool leagues to compete against your friends. To try everything Brilliant has to offer for free for a full 30 days, visit brilliant.org/Ellie Cytome or click on the link in the description. In doing so, you will also get 20% off an annual premium subscription. A big thank you to Brilliant for allowing me to make really cool videos like these. Now let's get back to the reaction. Oh, whoa, was that like the first hint of colour? Whoa, we're getting colour now. This is so weird, because in the last one we literally just had black and white. Okay, so we're... Whoa. We have a planetary system. This is cool. Love anything to do with planets and extrasolar planets, so... I'm getting excited now. Oh, he's getting a gravity assist from this planet. We're told... I'm actually not quite sure what this is. Oh yeah, gravity assist. Oh, sweet, okay. I was right. Always nice to write in these things. So especially when you post a video on YouTube, you don't want it to be wrong. Yeah, he's gaining a gravity assist from this planet, and this is very typical in the space industry. So I know that if you have seen the film The Martian, they use the Earth for a gravity assist, and that just allows them, essentially Mars is here, Earth is here. They were currently on their way back to Earth, but they then used Earth's gravity assist to get them back to Mars. The New Horizons mission, which was the first mission to take pictures of Pluto, which I know Pluto isn't technically classed as a planet, but they are one of my favourite pictures like ever taken of our solar system, I guess. And yeah, fantastic pictures. And that mission, because obviously Pluto is so far away, they used Jupiter as a gravity assist, and then Voyager 2 I believe used like Saturn, Jupiter and Neptune, I think, for a gravity assist. I could be wrong with those planets, but yeah, they used multiple gravity assists. Okay, gravity assist has meant that he's going much faster, and he's going to do it the same. He's going to do for all the planets. As long as he doesn't do the sun, because I think, well, it's not the sun, but for the star, because I think he might get sucked in. He's going much faster. He's addicted to the speed now. I bet his adrenaline's shot through the roof. Okay, cool. The music is fantastic as well. Oh my gosh. Don't do it, don't. Yeah, don't do, you're gonna get sucked in. Oh, okay, we've got it says impact imminent. Okay. Okay. What how is he gonna get out of this? Can he get out of it? His velocity's incredibly fast. Is he managed to? Oh whoa, okay, he's managed to get out of it. I mean, I don't think flapping the hat in real life would work. It definitely wouldn't work. That's a really cool planetary system. I like the use of colour in this animation, especially seeing as though... Oh, he's got 1% of the speed of light, which is fantastic. Magnets, cool. Okay, this is going to be interesting. But yeah, I like the use of colour in this. He's going to need some strong... Come on. I was going to say he's going to need some strong magnetic force there to suck him. Nice. It's working. Fantastic. And now we have a floating rod. Cool. I mean, I suppose there's a lot of space debris out there. Maybe not millions of miles away from Earth, but anyway. And now we have we have magnetic rings. This is like some, like, I don't know, like some game. Right, what is he doing? Oh, he's making a solenoid. Oh, cool. Okay, so he's basically making the rocket magnetic. Cool. That's so sweet. If only this was actually possible in real life, it would be quite cool. Like, if you just hop on a rocket and not worry too much about radiation or dying. Yeah. So he's going at 1% of the speed of light. He's getting there. Every step counts. 1.4%. 1.9%. So he's using these magnetic holes, rings, to propel him towards... okay. So the graph's moved. Whoa, so he's going at 80%... He's going at 80%... Right, hang on. He's going at 80% of the speed of light. Which is... yeah, okay. Again, this is not real. I need to remind myself this is not real. But that's... Yeah, that's absolutely insane. But the really cool thing here, and I'm loving the use of colours, and there's lots of blue and red in this, and yeah, there's some kind of like nice subtleties, but here you've got blue shift and red shift, so that's alluding to the Doppler effect, which, yeah, is really... Well, I think it is anyway. Which is really cool. Whoa. So what's nice is he's seeing things on such a large scale now, because he's going so fast. Asteroid field... How he didn't die going through that, I don't know. Comet, nebula. It's really hard to keep track of everything. Time dilation. Yeah, of course he's going to have time dilation if he's going that fast. I think that's what the colours mean. The blue and the... Whoa, what's he got there? Quasar, spiral galaxy. Oh, that's so cool. Obviously there's lots of physics in this, but it's quite astrophysicsy, which is more my area of expertise, so I'm happy that that's the way it's going. So he's currently going at 80, yeah, still going at 80% the speed of light. Okay, now we've got gamma radiation, I think that was. Yes, okay, nice, cool. Okay, I wasn't wrong. I panic so much in these videos because I get so excited that I just jump to conclusions and they're completely wrong. Like in the last video, I was like, oh, this could be the dot product and this could be this. And then it was quite literally like the complete opposite thing. So again, I've got to stop jumping to conclusions, but I'm happy about the blue shift and red shift, because that's obviously something that you see with the Doppler effect. So yeah, it's nice that we've seen that. Oh my god, we're going towards a black hole. I mean, I'm quite happy I'm wearing this top now, I'm not gonna lie. So we're going towards a black hole. I think that just said accretion disk. I love accretion disks. I did a module on it in university, absolutely love it. So yeah, the study of those are absolutely fantastic. Whoa. I love all the mix of colour now, it's fantastic. So Stickman is approaching the black hole. Oh, so he's going 99% the speed of light now. We have the event horizon, singularity, photon ring. Oh, this is so cool. Whoa, what? Did that just throw? Hang on. Where did that apple come from? Is this a white hole where things are getting thrown out instead of sucked in? I'm so confused. I didn't know, I wasn't aware that black holes threw apples at people, but here we are. So an apple's just been thrown at him. I do quite like the apple, because I assume that's alluding to Newton's apple on his head. It's white at the end. I am so confused. Don't do it. Oh, okay, he's done it. Outside perspective. So this is really cool. I thought with it being Stickman, he would go into the black hole. There's no doubt about that. But I think what's quite cool about this is, just on the topic of black holes, what's insane is that essentially from an outside perspective, so if I was watching Stickman here on Earth and I was watching Stickman go into the black hole, essentially as he approached the black hole, time, like because of the way that time works, I would look at him and he would be frozen and time would stop from my perspective, whereas he would continue entering the black hole, but I would see him frozen on the event horizon. And yeah, I just find black holes absolutely fascinating. So yeah, very cool. So he's waving goodbye, I think. I don't actually know what he's doing with his hat. Is he using it as an assist? I don't think he needs any more of an assist if he's going at the speed of light. Whoa, he kept the torch. Oh, that's so cool, okay. So it's showing the shift in gravity. I assumed he was going to get spaghettified at some point, and I think that's what is going to happen now. I think what this is showing is how the gravity at the front of the rocket will have much stronger influence than the gravity at the back of the rocket, causing this stretching, which is called spaghettification, which is it's a cool term, and it happens in black holes. Obviously, we can't prove that it happens because we can't make black holes and we can't do the experiments, but theory implies that is what would happen. Gravitational pulse. So I think there's the red shift and the blue shift, I believe, because everything in front is red shifted and everything behind is blue shifted. Is this apple gonna turn blue? Yeah, it does. That's so clever. Whoa, what the heck? He's gonna get spaghettified. Again, I love the soundtrack on this. The soundtrack on the previous one was fantastic. No, what the heck? Oh, so the apple's getting spaghettified. Oh my gosh. Yeah, okay, so the apple is now getting ripped apart. Why is Stickman not getting... Whoa, what the heck? So... Whoa, right, sure, okay. The apple has gone from a stem and now it's I guess getting broken down even more and more. So DNA now, phosphate backbone, hydrogen bonds, sure, we're going to go to quarks soon. Proton, quarks, nice. So it's showing the destruction of this apple, which is nice. There's a bit of biology in there. Is he going to make it? So where is he now? Is he outside of the... He's floating. Oh, so the singularity's there. Swimming, apparently. No. This is sorry, I'm just getting too excited. This is literally the top that I'm wearing. It's the Penrose sorry, I'm just getting a bit nerdy now. It's the Penrose diagram. I'm literally wearing this top that's, I mean, it's slightly different, but it's kind of essentially, I think it's pretty much the same. If you compare this, I'm so sorry. If you compare what I'm wearing to the bottom right corner here, yeah, it's the Penrose diagram. Oh, that's so cool. Okay. I'm so glad I wore this top now. I actually thought that the physics might have been like less astrophysics and more just kind of general physics, because physics spans such a huge domain. Whoa, there's 2 of them? What? What's going on? Probability waves. So is everything at the bottom wave-like? I'm rather confused. Why are there 2 of them? I mean, is this like an alternate him from a parallel universe? The apple's not okay. Whoa, okay, we're in manifold region now. We're in very complex physics and mathematics now. I still want to know what those little bubbles are. So there's 2 of them now. What is that? Is it a wormhole? It's a wormhole. Ooh, that looks weird. Whoa, what the heck? Hang on. That's him from before, isn't it? Whoa. So two of them from. So they're watching them in their past self. This is honestly, it's like Inception. They're watching themselves in their past self, but there's 2 stick men from different universes or parallel universes. I have no idea, to be fair, but this is cool. So they're watching their past self. That's where you got the rope from. I did wonder where that came from. I was like, that star must be generating some cool material if it's just yeeting out strings. One-dimensional open string, closed string. Got a bit of topology in there, lovely. And that generates the ball. Oh, so everything that was passed to Stickman originally is from alternate universe Stickman, or Stickman that's gone through the black hole. Even the rocket. Okay. And now he's turning it. Is he rewinding time, or is he Tipler cylinder? Rewinding time. Escaping particle, and oh my gosh, is that quantum entanglement? What on earth is going on? So they're I think they're rewinding time now, and they're seeing what they so they must have everything that, even the solar system, everything that was planted and we've seen in this first episode is they've generated it. Well, not generated it, but they've given him it. Aww. Why am I feeling emotional? Why am I feeling sad about this? I feel like it was a very well articulated story. Is this fantastic? Whoa! Hang on. Did they prank them? They pranked himself. They trolled him with an apple. That's quite funny, actually. So what? Whoa! Hang on a second. I am very confused. He's leaving now. we're back to stars like in the beginning. Oh, that's the end. Oh, I was hoping there'd be something else. Well, that was it. That was the animation versus physics. I hope you enjoyed. Let me know in the comments if you have any other recommendation for video ideas. Yeah, and I'll see you all in the next one.